Yeah, thank you. I'm very happy to have you all here in our session today and be able to share some of the work we did. And hopefully this is also helpful for you as some kind of a template for some future work. So I guess we can jump right to it, just like slide wise. Can you see my slides? Ah, yeah, I think they're coming. Um, okay, so what are we going to cover today? Um, I would be a very happy person if you walk away from this session today with those three things. So my goal is that you understand how such a project like this Euro 2024 dashboard can work end to end, including Metabase, but also in general when we look from data extraction until visualizing the data at the very end. I also want to cover data modeling a bit. So ideally, you walk away and understand why it makes sense to use models, Metabase models, but also maybe like general data modeling techniques. And so when it makes sense and how you would use them. And I'm very happy if you also walk away from this session with a few things that you learned regarding Metabase. So I'm also trying to cover a few tips and tricks that are maybe a bit more advanced. That might help you in your day-to-day work if you're using Metabase already, or that if you don't use Metabase already, that just give you a few insights on how you could use it potentially. So, but before we jump into things, what I'm very curious about is you might have seen this dashboard already. Maybe not everyone. That's not too bad because we will cover just a few things there as well. But I would be curious if there's anything specific that you saw in the dashboard that you want me to cover. Feel free to tell us in the chat. Margaret will help me monitor that a bit, and then we can try to adjust our presentation a bit at the very end. So just post the stuff in the chat.
And I just reshared the link to the dashboard in the chat. So if you haven't seen it, this is the exact dashboard Thomas was talking about.
Nice, thank you. Okay, so then let's jump into today's session. So what you see here is kind of an overview of what we want to cover today. So this is like a typical end-to-end flow of starting off with raw data up to the end where you visualize stuff in the dashboard. And in our case, we have been working with the Sportmonks data. So that's just a sports data provider. You could use any other one as well. For us, it was just pretty convenient to use them. So this is why we ended up using their API. This API usually has a certain format where you extract data from. And this all happens in a so-called ETL flow, or there's also ELT flowing around. ETL stands for extract, transform, load. So you basically extract the data from somewhere, do some transformation on it, and then load it somewhere else. In our case, we load the data into a Postgres database. This could also be any other type of data warehouse or a database system. And then on top of that, so this database is connected to Metabase, so a Metabase instance. And on top of that, we have some kind of a data modeling layer, which we use to bring the data into a format that's easier to analyze for us down the road. So this is basically where we take the raw Lego blocks and try to build pre-built Lego equipment already. So the cars, the houses, and so on, so that we can more easily use them in our dashboards at the end. What I want to double click on is that this is a typical flow that you might see in the data land. It's not super specific to this project, but obviously there are many approaches to those types of work. But it's pretty common that you see an approach like that where there's any data source from your side, like you might be using Stripe, HubSpot, Salesforce, any other sources, maybe Google Sheets, where you have your data stored. And then you have some kind of ETL process to dump the data into a data warehouse. So it could be BigQuery, Redshift, Snowflake, whatever you're using there. And then this data is, in our case, connected to Metabase, could also be any other BI tool, obviously. But since we are here at Metabase, we talk about Metabase more specifically. And for Metabase, the cool thing is that technically you can also upload any arbitrary CSV file. This is something that I recommend a lot for data that is not changing that often. So if you have something for an ad hoc analysis, for example, or where I used it a lot in the past, is that we had some company goals, so like yearly goals, quarterly goals that ideally don't change too much. I know the startup world as well, so sometimes those goals change on a daily basis. But if you have those goals, let's say fixed for a year, then you could upload the CSV file to Metabase and join it with your actual data. So this is how you can compare the performance, how you're doing compared to your goals. This is also a pretty handy way of using the raw data. Yeah, and then typically you have the setup where you have some kind of data modeling. So it could be Metabase data models. It could also be in industry standard, the folks use DBT a lot, which is a tool to basically model your data. There could still be something like Metabase on top, where you let the business users create some data models that they can use and consume down the road. So that's just so much for that part. So see this as kind of a more generic template. No, it's not super specific for this type of project. Okay, but now let's jump into the steps that we want to cover today. So I want to start off by looking at the raw data format real quick. So don't be afraid. I hope we will not get too technical, but I want to show you a few things that can be really tricky with that type of data. It's also not too bad if you cannot read everything exactly. I will just walk you through some stuff. So the SportMonks API has many kind of endpoints where you can request data from. And here I just pulled one example from this fixtures endpoint, which is basically the goal, not the goals, the games that happen. And there you can pull a bunch of metadata from each of those games. So like the events that happen, the goals, substitutions, red cards, yellow cards, all that stuff. And what you get back is a huge JSON file with a bunch of information. And it has certain things like IDs, like a season ID, for example, like a name from the game. Here we have Germany versus Scotland, in case you cannot read it. And then what you see down here, also the collapse stuff, is that there's a lot of nested information. So like the game events, the goals, for example, they are nested in here. And as you can imagine, this format is super, super hard to analyze in a BI tool. So we need to do something about this and bring this into a format that's easier to use. One thing I want to double click on, because we will use this later, is this type ID. So for each of those events, it's a specific type of event. So as I said, it could be goal, substitution, and so on. But it's not written there that it's a goal, but instead we have this type ID. So SportMonks works with another table that has all types in there, and then you could look up what type of event that is. So that's an information to keep in mind, because we will use this later in the data modeling step. Yeah, but what you need to take away from this is the raw data can be in a pretty weird format that is not so easy to analyze. And this is why we need to do some data modeling or transformation on top. And how we do this is that we already do a small part in this extract, transform, load step. And in our case, some examples of transformations that happened during that step was, for example, cleaning the data. So we had cases where the timestamps were in different formats, or you had some floating point numbers where sometimes it was a dot as a decimal separator and sometimes it was a comma. So we would need to take care of those type of things to bring it all into a format that we can handle later down the road. Another thing that we worked on was adding new columns that makes it easier to join the data later. So there was, for example, a season ID where it's like, okay, this is the Euro 2024 Cup, and maybe there was some cup from the years before. And to be able to work with that in an easier way, we also added those additional columns from the data. Another interesting thing that we did, which we will also cover later in the session, is mapping the ball coordinates to a region on the pitch. So if you saw the dashboard and looked at a game, at the game stats tab, you might have seen that there are like those heat maps, which we will see later as well, where there are certain regions on the pitch. And depending on how many ball coordinates we see, you see this heat map evolving there. So mapping those coordinates to those regions is also something that, for example, happened in this transformation step. And then the data was loaded into Postgres. And for that, we use two types of jobs in this case. So the first one was kind of a one-time loading job. As I said, don't be afraid if you cannot read the code. That's just like for demonstration purpose. If you want to read the code, by the way, it's open source on GitHub, so we can also share this later with you. Then you can also try to run this on your own as long as you get a SportMonks API key to run this for yourself. But we basically had those two types of jobs. The first one, the one-time load, was basically to get all the initial data that we required. So things like the venues, the types that we just talked about that Sportmonks uses, countries, the participants of the tournament, already also some games and stuff, so that we have all this information preloaded. But there is one problem to that job, and it's that it takes quite some time. So to load all this data, we need to wait for a couple of minutes. I don't recall the exact time. Maybe let's say it's 5-10 minutes or something. So it's a quite a heavier job that you cannot run all the time because it would consume a lot of resources. And to overcome that, since we want to keep our dashboard up to date, we created another job that only loads the data for a specific season, which means in our case only for the Euro 2024 games. And this job basically runs every 3 minutes and only loads a subset of the data. So not everything, but just a smaller subset, which means it's faster and we can run it more often to get the latest up-to-date data. So you see, this is not really a real-time dashboard, even though we sometimes advertise it like that. And the reason behind this is that usually in those football games, there's not so many things happening at the same time. So it would be different if you take like an ice hockey game or basketball game or something like that. There's way more stuff going on, which is why we said a sweet spot for us is refreshing the data every 3 minutes. And this is like still keeping us very up to date with the stuff that happens. And we don't need to run this job all the time, all over again. So this also saves some resources. Okay, so that's the extract, transform, load part. As I said, the data then landed in our Postgres database. And now it still was in a very raw format that was kind of hard to analyze. And what you do on top of that is usually that you try to bring the data in a format that's easier to analyze down the road. And as I mentioned earlier, the mind model that I always take for that is the Lego block. So imagine the raw data is all your small single Lego pieces. And now if people in your company want to work with that data, everybody would need to start from scratch and take all the tiny Lego blocks and assemble them. And then they might want to build houses, they might want to build cars. And so everybody ends up building their own houses and their own cars. And they look quite different to each other. So this is one thing. So everybody has a different way of analyzing and pre-filtering the data, even though they want to achieve the same thing. So a house might look similar, but still be different. And what you can do instead is that you just pre-build those houses and those cars and whatever Lego pieces we have, and let your users use them. So if they want to build their Lego town, their dashboards, for example, you have already some pre-built house templates and some pre-built car templates, and they could just use them, and it's way easier for them because they save a bunch of time, and they might not do any mistakes that suddenly a car only has 3 wheels because they forgot to add the 4th wheel. So this is how you can think about this data modeling layer. And I also want to show you a couple of things that we usually do in those types of layers. And one of the things that I think makes a lot of sense is, especially if you have this really raw data, then often you need to join a lot of tables together, which also kind of maps well to this kind of Lego block assembling. So you need to join certain things together. So maybe there are some tires that are already pre-built somewhere, and you, I don't know, have a window piece somewhere, but you need to join them all the time. So everybody would need to join them all over again. That's a super annoying thing. And this is something we can just abstract away and do for the users and build this into a new data model, which is a table that people can just use down the road. Another thing that also can happen in such a modeling layer is that you reformat the data, or that you also add some custom columns. And in our case, we have this example, which we'll also look at later, which is a model that looks at goal events. And there's one custom column that tells us whether this goal happened in overtime. And this is a pretty simple logic now, but I think you can imagine that even the simple logic of, okay, like, are there any extra minutes in this event time? If yes, then it's in overtime, otherwise not. Even this can be different if another person tries to do the exact same thing. And the same applies to your business. So if you model your data, your orders, your product categories, whatever, you might apply certain business logic that if you don't model that, everybody needs to apply that on their own. So it makes a lot of sense to abstract that away and pull it into a model so that nobody needs to think about, oh my God, what was the logic of whether a goal is in overtime or not. They can just use that and consume it. So they don't need to question themselves on how this is calculated, just use whatever is there, and you are doing the heavy lifting for them in a single place. Another very common thing is that you want to pre-select specific data. So we want maybe to filter out data that should not be used from the business side, or in our case for those goals. As I told you, they are certain event types. And what's interesting actually is that if you look at those goals, there are different types of goal, own goal, and penalty. And if you don't look too close to the data, you might miss out on this penalty type. So if I tell someone to analyze goals and give them this events table, they might forget to filter for penalty goals as well. And that's something we can do in our model again, once more, to just basically take this burden away from the user and do it for them. And the last thing that's also pretty interesting is when you want to calculate certain metrics. So there's one example in this raw data where it might be hard to read. So this fixture statistics, basically there's for a game, there are multiple stats, like how many shots on goal, how many shots on target, whatever. And we wanted to have this on a team level. So for a team and a game, we wanted to know what are those stats. The problem was that like every stat was a new row in this table. So basically there was one that was like, okay, so this is, I don't know, shots on goal. This is the value. This is the team. And then the next one was red cards. This is the value. This is the team. And we wanted to bring this in the format that's easier to analyze, where basically there's one row per team, per game. And then you have those different columns with those stats. So that's also something you can do in such a modeling step. But now a lot of theory around this modeling. I actually want to show you one example, which is this goal model here. So there you see there's like a lot of information, since we also want to use this data in a bit of a different way. But you see there are some kind of IDs and columns related to the goal. But what's more interesting is if we look at this query definition of this model, then you see on top there's like a lot of joining going on. So you see really joining a lot of data already. Also those types that we just talked about. And you see that we only select specific fields because not every field is interesting for the goal event. So for example, there's a flag that says whether someone was injured. That doesn't make any sense for the goal. That's there for other events. So we just don't need this in our table, so we can avoid some confusion already. What we also do is what you saw earlier. So we have this overtime logic here, for example, where we create some kind of business logic on top of the data. We pre-filter it. That's also what you saw in the slides, if you could read it. And then, yeah, there's some sorting going on, which is not so super important. The other thing I want to quickly double click on is that if you create such data models, then another important aspect of it is that you ideally try to document it well, so that people know what data they are using. So in our case here, I also didn't add a lot of description and stuff. But if you want this to be used by business users, it makes sense to actually describe what certain columns refer to, so that they have an easier time working with the data down the road as well. Another thing that I would always recommend you doing is, like, whether it's in data models or in the raw metadata of the table, is that you also try to define those semantic types. So Metabase has this semantic types here that you can set. So for example, if I have a foreign key column like this here, I could set the semantic type and tell Metabase, hey, this ID field actually maps to this other table here and to their ID field as well. And this is super powerful if you do those types of things in Metabase, because this allows Metabase to already know some things about your data, and then be smart about certain things that you do in the app. So if a user then uses this data to, for example, join stuff. So if I go back to the query, if I set up those foreign key relations, then I would just need to select to join the types, and it would automatically fill up those things, for example, for your users. So this is something that makes it really easy to use your stuff later on. What it also allows you is that if you want to filter, for example, you don't need to explicitly join data. So you see here those things that have this join icon here are tables that I joined, but you also see that I can filter on other tables that I haven't joined yet. So the season table, venue table. So I could filter on fields here that are not even part of my data. But since Metabase knows how to combine those tables, you can just use it and filter it right away. So you see that can get quite powerful for your users because they don't need to know about those relations. They can just naturally choose from those. Okay, so that's kind of a quick example on these data models. And then the next thing I want to ask you is whether you actually used Metabase models already today. So in case you're using them, feel free to write in the chat. In case you're using them, I'm curious what you're using them for, and whether you tried using them already, whether you found them useful or not useful. That can also help us inform our product development on where we need to further improve them, or also like how you use data modeling in general. So if you want, feel free to shoot some things in the chat, and maybe we can also discuss later in the Q&A session. Okay, so now, yeah, Margaret.
Yeah, I'm just appearing here to let you know we haven't had any questions specifically about the dashboard. So feel free to jump in whenever you feel ready.
Okay, awesome, great. Yeah, that's actually the next topic. So now you saw just a quick recap. We had some raw data that we quickly looked at. It was in a pretty unclean format, or at least in a format that's not easy to analyze. It's more for like building products with their API. We extracted this data, transformed it, and loaded it into Postgres. There we had this data modeling layer on top, and now it's about to make the data shine. So we turn information into insights and make it able to monitor that data. And for that, we built the dashboard. And now I want to quickly jump over and show you a couple of things that might be interesting to share in terms of how we did them. So I created another dashboard. That's not really a dashboard, but rather just a dashboard with text cards. But this would be my plan on what we can cover. In case you have other things later in the Q&A, maybe we can also quickly cover them in case they are not in this list. So the first thing I got asked a lot about was how we actually managed to display images in tables. So if I go to the dashboard, so in case you haven't seen it, this is like the first page of the dashboard, kind of an overview page. And sometimes we have those tables like this one here, where you actually see the logos of the team. So in this case, it's the flags of the countries. And there are also other things where you might see the player image. So like this one here, for example. And a lot of my former coworkers and friends also ask me, hey, how did you actually do that? I didn't know that this is possible in Metabase. And it's actually not that difficult. There are just a few tiny tricks that you need to know about. So to talk through them, I'm opening this other data model that we have, which is team stats. So basically for each season and team, we have one row with certain stats. So that's what you also saw earlier, this kind of thing where we aggregate all the metrics together. And there you see that the logo here is also the country flag. How this is set up is pretty basic. So if I go to my metadata here and click on the logo, there is one or two things that you want to keep in mind to be able to use that type of visualization. So the first thing is that you either want to select no specific semantic type, or if you select one for image URLs, then you need to say that this is an image URL, which is actually what it is behind the scenes. You will see in a second. And then what you can do here is that we have this display as selector, and then I can choose how I want this to be displayed. So I can either say, okay, display as text. So this is how you see how the raw data looks like. I could display it as a link. Then if I would click on it, I would go to that image. You can also customize how this link would look like. Or I can say, hey, actually make this an image, and then it's displayed as an image here. Now, if I go back, just not break anything, there's also another way of doing this. If you set up your semantic types correctly, then in the table itself, you can also choose how this thing is being visualized. So I go to the visualization editor here, and if I go here, you see there's also display as, and I can choose from those options as well. One thing to keep in mind is that you can use this field to also aggregate. So I can, for example, count how many rows we have per logo. And then in the table result, I still see the logo like that. If you want, however, to visualize it at as a bar or something like that, that doesn't work too well. So there you just see the raw text. So that's not working well, and that's not what you want to do. But in table views, you can just use the field and display image links as the real image in Metabase. So that's number one. Number two, what I also got asked a bunch of times is about the filters. So if I go to this dashboard, you see that here in the filter, we have this list where you can choose from. So I could also type in 2024 and it searches for this championship and I can select it from here. The cool thing is that behind the scene, this is actually an ID filter. So it filters on the season ID. So if I would not set it up, what happens is that you would just see those ID values. And maybe in our public dashboard, you might have seen that on our website because we still had a small bug in some of the older versions. It's fixed now. I just didn't update it yet because I didn't want to introduce a new problem or something that wasn't handled with the old stuff. But usually this thing still filters on these IDs. But the cool thing is, from a user experience, I don't need to know what this ID means. I can just like use the natural naming for that. And that's also pretty simple to set up in Metabase. For that, what you want to do is that in the Metabase admin, so in case you're not an admin user, then your admin users could do that for you. But in the Metabase admin, there's a section where you can define certain metadata about the raw data you're connecting with Metabase. So in this case, you see that we have this fixtures table, and then there are all the columns listed here, and you see that there's already some semantic types set up. Metabase also tries to be smart about that and try to infer certain semantic types based on the names of your column, but it doesn't always work 100%. So it's something where you can also proactively give Metabase more information and then make it better for your downstream users. So, but how do you set those things up now? So if we have a primary key, so the entity key here, see on the ID, there's also a name column that you see here, which is the entity name. And now if I go to the detailed settings of this key, so if you click on this gear icon, then what you see are two things. So you can decide how filtering on this field works. And there you want to choose list of values. And then you can choose how things should be displayed. So the default is using the original value, but you can also select custom mapping here. And then this mapping, this is automatically populated using this entity name that we saw. So this is automatically populated, but I could also adjust it and manually add some mapped values if I wanted to. So this is how it works for the primary key. And then there are things where you have a foreign key, and there it's even easier. So if we take the season ID here, for example, you see that I set it up as a foreign key and I say, hey, this thing actually points to the seasons table. And then in the gear icon here, you have the same thing. So you want to choose a list of all values. And then in the display as, you have the same options as before. So using the original value or using a custom mapping. And you can also choose use foreign key. And that's pretty cool because now I can choose any field of this season table to be like this value I'm mapping to. And in our case, we use the name. So this is just automatically mapping it to the names. And then if you have set this up, I can go back to our dashboard. Another thing you want to do on the dashboard level is that if you create those filters here, you see that there are different types of filters. And in our case, we choose this ID filter. And yeah, in this case, we also have a default value that we choose. But this already makes it work that you can then show the mapped values. And I think how it happens behind the scene is that whatever fields you connect here, it's looking at that mapping and then trying to see whether it has field values, and then it would show them this way. So in case you don't see it, make sure that you double check on which fields you are mapped to and whether those fields actually also have this custom mapping somewhere. If not, this could be that it doesn't show it correctly. Okay, so let me keep this open because it might be that the next thing I want to show you is actually there as well. Ah, no, the next one is Heatmaps. I also quickly just saw a question here whether the mapping in the models is available in the free version. Yes, that's available. So all this semantic type setup that you saw, this is totally available in the free and open source version. So you can easily just also set this up there. Okay. So now the next one, already talked a bit about those heat maps. So let's maybe first look at one of those because there's some interesting stuff to show. So this is this kind of heat map that you might have seen. So in this case, this is a ball heat map of the first half of a game. In this case, we didn't filter for a specific game yet, I think. This just shows all the games that we have in the database and kind of a heat map of it, which is why it's like pretty red everywhere. But you see, like, you can still see those lines of the pitch here a bit. So the circle in the middle and those goal lines. And then we have a grid where we basically map those ball coordinates into. This grid, you also see the region name there if I hover over it. So it starts at the left bottom here with the region 0, 0. So I was not really good in naming things here. This is 0, 0, then it's 1, 0, 2, 0, and so on. So this grows. Same to the top. So the next row would be 0, 1, 0, 2, and same thing here. So diagonal and so on. So these are how those regions are named. And then we are basically mapping those coordinates into one of those regions on the pitch. What this uses behind the scenes is a simple region map. So this is kind of a hack that I actually applied because usually you use this for maps like this. So you might have the United States, maybe, I don't know, in my case, a map of Germany, of the German states, and I want to see how many, I don't know, many users we have in each state, those types of things. There's also something like a world map. But in this case, I kind of create a small hack around this because usually this is all information that kind of maps to somewhere on the globe. In this case, our soccer pitch is not really somewhere on the globe. So behind the scenes it is, you will see in a second, but it's nothing that's really on the globe. This could map to, like, your use cases might be that, I don't know, maybe you have a map of your factory and you want to see where certain processes happen, how many products are assembled in a certain line, how is the performance of products, whatever. So you might have a certain map of things that's not really a map on the world map, but rather a map of some regions that you have in your production line for your products, whatever. And this is maybe something to keep in mind that you could apply there as well. All you need here is to create this custom map. And this is a setting here in Metabase where you can upload this GeoJSON file. So these custom maps work with GeoJSON format, which I will not go into details because this will just be too much for the session, but just that you heard about it. And what you do is that you have some kind of URL where you get this from. So in our case, this thing is open source in our GitHub repository as well. And yeah, then you point it to that GeoJSON file. And then you need to tell Metabase what properties of this GeoJSON file map to a region. So in our case here, you see those region identifiers that I showed you earlier, and also what specifies the display name. So those can technically be different. In our case, we just use the same ones. So you can upload those maps then to Metabase, and then they are available in the setting there, as you saw it here, when you want to choose a region map. So then this would pop up here. How this looks behind the scenes is the following. Let me see. So here is the pitch map in GitHub, and I might need to zoom in a bit. So this is the GeoJSON file. GitHub already renders it for me, which is quite nice because now I can show you the trick behind the thing. So if I zoom out, you see that this football pitch actually really lies somewhere on the world map because you always need to use those latitude, longitude coordinates. But I just made it so small that it's quite next to the equator, so pretty close to 0, 0. If you make it too big, so that's a learning I had. So if you, I think I'm also only using coordinates between 0 and 1. If you make it too big, then it scales across the globe. But since the globe is a ball, and if we want to look at this map in a 2D manner, we always need those projections. So if you now create the soccer pitch, it looks really weird because it's basically stretching it across the globe. So that's something to keep in mind. You want to rather have this using very small coordinates in here. But that's all the trick. So you create this GeoJSON file, and then on top of that, we basically build our region map. So it's maybe a small hack trick you hopefully can also use in the future. Okay, so that's it from the modeling and questions part. And now I want to show you a few smaller tricks on the dashboard side, which are also quite interesting. So if you used the dashboard already, just go over here once more, then you might have seen that there are certain things you can do there. So in our public embedded version, there are some limitations. So I cannot do any drill downs or something. But if you have your local instance, of course, you can do those things. So I'm on the dashboard, and I could, for example, say, hey, like there are certain goals in the extra time. I'm interested in what goals those are. I could click here and show me those raw goals, or maybe even split this up by something. So it could be that you have a bunch of monthly orders for each month, and then you want to understand where those orders in this month come from, and you might be able to even split them up by category, by country, or stuff like that. So that's a feature I really love about Metabase, that you can easily use this drill down functionality. But that's not what I want to show you. What I want to show you is that you can customize a bunch of things. So what you see here, for example, is that we have this game stats link. I could also click on the home team. And if I click on this game stats, what happens is that it opens this other tab and already has this game pre-filled as a filter. So I just click on that because I want to explore the stats around that game. And now I dive right into this tab, everything pre-selected, so I don't need to do this on my own. And yeah, then you see there's all the stuff from this game, certain stats that we see, and I'm a happy customer. Maybe I'm also interested in like seeing how Spain performs. So that's the exact same logic. I can click here, go to the team stats table, and the stuff is pre-selected then. So now let me go back to show you how you actually do that. To achieve that, you can go in the edit mode of a dashboard. And then if you scroll to any kind of card, so this also works with those here, you always see this click behavior menu. If I go on this click behavior menu here, then you see there's click behavior for all those other columns is like just opening a drill down, a drill through menu, but I also have some that go to a custom destination. And I would just want to show this really quick. So I could just go on any column, and then there are different types of options. So you could say, okay, if I click on that column that I want to update a dashboard filter, then I could choose the filter and choose how I want to update the value. I could also go to a destination, which could be a different dashboard, for example, that maybe shows more details about something. So imagine you have a company overview page where you see your monthly revenue. And then maybe if you click on one of those revenue tables, you are led to another dashboard where there is some more detailed data about the revenue. So this could be one of those use cases. You can also go to a saved question or to a custom URL. This is what I have been using. So if I go to those here, you see that I'm going to a custom URL. This is a small hack in that case, since it's like a public dashboard, and I want to go to a specific tab of the same dashboard. That's a functionality we currently don't support, but I already advertised it a lot in our product team, that we hopefully also add this in the future, that you can also select to go to a tab on the same dashboard by also applying filters. But that's something, feel free to explore this on your own a bit more in detail, but I wanted to show you that those types of things are also possible, where you can actually really customize the user journey. And this is something that if we build dashboards, we should always keep and focus on who our audience is. So who are we building this for? And how do we imagine them working with this dashboard? How would they explore things, walk through stuff? And this is a really nice trick you can apply for some storytelling, or at least guiding people through a journey within your dashboard or your Metabase instance. Another thing I wanted to show you is that we sometimes have this use case, like in the game stats. If I go back here, then you see right now, game is over, Spain won the cup. Okay, everything nice. There are a couple of stats we see here, but there are also those cases where, not right now anymore, but before a game actually starts, we don't have all those stats. So what would happen with this dashboard is that you will see a bunch of empty states for all of those cards, which means if I'm interested in stats that really have a value, like those pre-game winning odds, for example, or the age distribution, then this is something which is really hidden behind a lot of clutter, because all this part here would be empty states, that would be empty state, that would be empty state. So until I reach those stats, there's a lot of empty things I need to go through. And that's not a nice user experience. So what you can do to overcome that is that you actually hide those cards if they don't have any results. And for that, every card has those visualization options. So there you can do some customization on top of the, the question that powers that card. But you can also choose this option here to hide the card if there are no results. So you see, this is what we are doing for those things, for example. And then if you would open the dashboard pre-game, where there are no stats, then just all that weird stuff is hidden. And I only see the things where there is really some data. So this can be very helpful if you want to hide things in certain cases that your users don't get overwhelmed. Then this might be a very nice approach to do so. And the last thing I want to show you is another thing that also happens quite often if you build your dashboards. So let's maybe take a different example than what we have here. So imagine you build a dashboard that's about all your orders. So let's say you have an e-commerce shop, you want to monitor your orders that are going on, and you might have a dashboard where there is one filter for a specific product on top here, and another filter that is for a specific product category. Now, if I select a product category of, I don't know, let's say mobile phones, then in my product filter, that if I want to use that as well, ideally I don't want to show all the, I don't know, watch items as well, but only my mobile phones. So if I then want to further filter down that category to only see specific products, ideally I only want to have the mobile phones listed. And this is something you can also achieve with the filters, and that is called linking filters. So in our case, it's not product categories, but we have seasons that we select. So this is a mandatory filter. So there's, I don't know, you say this is the 2024 Cup or another Cup, then I don't want to show all the games from previous or different Cups and also all the teams. I only want to show the games and teams that actually are part of that season that I selected. And for that, if you go to this filter, you might have seen this tab linked filters. And you see that the game filter is linked with season and the team filter as well. So which means whenever I change the value of season, it would also apply the filter to the available values on the team or on the game, which means if you translate it into normal language, this means when I select the Euro 2024 season, I will not see games from any other seasons. So this can also be quite helpful to create a nicer user experience for your users. So if I go to the game stats here, for example, see there's like Spain versus England, and now I would like see all events here, and you see they are all from 2024. If I change this to, I don't know, let's take the last championship, 2020, update the filter, and now I go to the thing here. So now we still have this pre-selected, but if I unselect it and try to choose something, you see, now there are different events in here. So those old ones don't have the dates in there. We just added them for the 2024 one, but I guess you get the idea. So this helps creating a nicer user experience because you don't confuse the users with things that are not there. They might select something and suddenly the whole dashboard is empty because they chose a filter combination that doesn't make any sense. And that's basically it from the stuff that I wanted to show you. Before we jump into the question answering, I just want to do a really quick recap of what we did, because there was a lot of stuff that we walked through. So first of all, if you walk away with those things, then I'm very happy. So what we did, what we learned today was that models can be helpful to bring your data into a format that's easier to work with. So always keep the Lego blocks in mind. So don't let your people build the houses and the cars, build them for them so that they can build their Lego town quicker. If you spend time on setting up those semantic types that I showed you, that can be a really good time investment because this makes Metabase even more powerful. You saw some kind of click actions that we applied that can help you guide users through their journey in the interaction with the dashboard. And you also learn about those custom map tricks. So maybe that's also some more advanced stuff that you might be able to use in your company as well. And that's it from this presentation side. And now I'm really looking forward to the questions from your side. I keep this slide open because then we can maybe also switch to other stuff that you folks are interested in.